Right, so what had happened was I was looking at writing a small little function for playing with strings like you generally do. So you have an array of byte of strings, and you can go and say, okay, let me parse the first 5 or 6. So you just have an I index, and you can just get whichever character like you do with C strings. And I realized that it works, but the moment you have emojis or Unicode, it doesn't work anymore, because what is the length of that character? It's not a byte. It can be anything from 1 byte to like 8, 10, whatever. And we'll look into that. So I filed a radar with Apple saying, hey, this is not right. And yoo-hoo, my claim to fame, it was fixed. So I have like a little bit thing there that I actually had a radar to my credit. Right, now, what are strings? So a string is nothing but a collection of characters. And those characters can be Unicode, can be ASCII, can be anything. It is also a collection of extended grapheme characters. Now, this is one thing which is like one of those things, if you read the Apple documentation, it talks about. What exactly is that? So that's the complex glyph that says that it's not just, 65 for A, but it actually is 0x, and then depending on is it in Unicode, non-Unicode, and so on. You can access the strings as Unicode scalars, UTF-8, UTF-16, or character views. So it kind of translates for you between those formats. And instead of getting the length of the string, because I think mostly what we do is like, if length is 0, then we say the string is empty. Or if the length is 1, then we say it has 1 character. Don't use that. Use isEmpty. That is the recommended way from Apple and Swift. Right, so strings as collections. Now, how many of you have been counting on your characters? Not as in like personal characters, but characters. So you have like string.characters.count. You don't have to do that anymore. So you don't have to do all of this. .characters.count.
What's with the underscore?
I was actually writing a couple of things together, so I had to have the first iteration with the proper names and the other one with the underscore. So it's just, when you copy and paste, it leaves those kind of things. So if you wanted to find the number of vowels, this is what you would do with Swift 3. You would actually count the number of characters using characters, or you would actually go iterate through each for character in HTML string.characters and then check that if it is one of the vowels, and then you increment it. With Swift 4, you don't have to do all of that. You just say print string.count. And if you write an extension, you can even write a length, which returns this. So you can actually use length just like you use with other languages. And the same thing now. It also has a contain, so you can say, okay, if it contains that, because in the previous versions you couldn't have contain because string and characters were not the same. So you had to cast from character to string and then back. So that would now be as simple as that with 4. So lesser lines of code, much more easier to read, and more usable. Multiline string literals. Now, this is something which has been really, really interesting, and it has caught up with Scala. Anybody use Scala? I just saw that this afternoon, so I'll be very honest with that. Sorry? Matthew?
I hate it. It's horrible, but I've used it.
So Swift has caught up with Scala in terms of string literals. Now, how many of you have written JSON and you remember, or this kind of code looks very, very familiar? Right, this is a text, /n, this is another line of text, /n, and then you go like, is that like /n? If you miss a slash, then it just prints out an n and doesn't give you the, or if you write JSON, familiar? And yes, but sometimes you also create it on the fly. And worse still, if you use HTML, web views, or whatever?
You just react to that.
Not only React.
Who taught you to such hate speech?
So now, all you do is this. You say string this is the text, this is the second line, this is the third line, all neat and clear, and you can see it. Now, how many of you actually knew about it when Swift, I think 0.6 they introduced, you could actually use underscore in the numbers to separate them or kind of group them? I'm sure only a few. A lot of people were surprised after 2.2 saying, hey, you know what, we can actually put underscores and separate the, group the numbers. So similarly now, nice, neat, and visible as you want. Now, there's one very interesting thing here. Note that pink line. That determines how the text would be rendered. So the last quote tells you exactly how it's going to be rendered. So if you look at this example, you would actually get 2 spaces for JSON string. And with the HTML example here, that's how you would get it, irrespective of the number of spaces before the 3 quotes.
That's beautiful.
But I ask
Yeah, sure.
question with just for this example of title and body text. Can you make them multi-line and edit?
Absolutely, you can do whatever you want.
So I can have one sample page 1, one sample page 2 down, and then the title will come up correct.
I'm sorry, I missed that bit.
Yeah, you got the title.
Mhm.
It's in the back. What happens if I make title multi-line?
That's
In theory, that would work fine. Yeah.
more about
Yeah.
HTML question. It would be fine.
It will work. I mean, as long as you've got the strings right, whatever content is going to come there, it'll be all fine.
But I guess now that I just realised what you're asking, would it indent the string to the same
String
level?
interpolation is a string interpolation.
Yeah, but-
It will drop it in exactly as it appears in your other string.
Just a question, what about trailing spaces?
Oh, sorry?
If you have a space, actually, at the
Are you
end,
actually suggesting they should?
No, so I'm coming to that. Now, there's a couple of things here. Now, this is about the first line. So that is how you kind of align it. What you're asking is in here, a new line escaping. So sometimes you have like a big string, oops, an error occurred because you did not supply your username and password, which was incorrect. And I don't know if, I mean, there are people who write those kind of messages. But so when you look in Xcode, you go from line after line after line, something like that. Now, because this is Keynote, you actually see it wrapped. But if this was Xcode, you'd actually see it in one line and you'd have to scroll till you see the last character. Now, the new thing with this is you can actually write something like this. And I had to actually put those little yellow line returns to answer exactly what you were asking. If you had an enter here, irrespective of that, it will still take it at this point. It emits or it kind of ignores all that extra white space.
Same as bash, basically.
Sorry?
Same as bash.
Yeah. Yeah.
Maybe I missed that. Are you saying the yellow symbolizes the character that you drew or the enter space? I mean, enter key.
No, so those characters are basically enters, so they're representing the new line.
Yeah, okay.
So if you put a slash, that is the same thing. It's a one single line. There's no spaces or what you call carriage returns in there. When it prints as one line. It strips out all the other stuff, the white character spacing in there. Now, Unicode handling. I'm sure if you've tried to actually download a zip file, that is most commonly what you might have ever seen. Now, how long is a piece of string? This particular emoji in Swift 3 is 3 characters long, which has a woman, a heart, and a woman. I'm not being gender specific or inspecific, it's just an icon. If I use the other one, then I would have to explain why I use the other icon. So please don't ask me about that. In Swift 4, it is just one character long as it should be. Now, here's an interesting one. Yeah.
If Swift gets it right, why does Slack get it so wrong?
Oh, man.
Because Slack uses JavaScript and not Swift.
Sorry, that you said, Jesse.
No, that's Matt. My particular radar to Apple on the emoji issue was actually based with a couple of guys who were talking about JavaScript and how Unicode works. So, before I do that, have a look at this little thing if you can see it from the back. This is an icon of two guys with a love heart. And if you replace all occurrences of a guy with a girl, it replaces only the first one. With the other one, there are two women, and if you replace all occurrences of a woman with a man, it changes the first one again, and it changes the emoji to a woman and a man. Now, this was some of the things which weren't really working well, so this was like a bug, obviously. Right? Now, have a look at this. So you got a relation. So it's a string. This is a woman. And you add 200D, which is basically Unicode for a joiner, with a heart, and then another joiner with another woman, and that's what you get. Sorry, my bad, I see that in the preview before. So that's what you get if you do that. And that is the proper way how strings, especially when dealing with Unicode, should work. Because if you were not using emojis and you were using a language, then you wanted the glyphs to actually work together, like any language that uses Unicode. Some of the glyphs actually kind of merge together and form different glyphs. So,
Korean does that.
yeah. Now, Arabic, Hebrew, a lot of Indian, some of the Cyrillic languages, I believe. Now, if you did relation, because now relation are two women, and you did replacing occurrences of the woman with a man, you have gender equality. So now you can have both kind of relationships. So Swift gets that right, and Apple has been inclusive, so points, full points for them. Sorry?
Much better than a postal vote. Sorry.
But you're going to register before the 14th. Right. Here's another example. So you can actually create a string called family, and you start with the father, which is basically a man. And then you add another one, which is the mother. And then you add a daughter, and if you can see what happens, the emojis start to change. So if you run this in playgrounds, you'll actually see the emoji on the side for the string. And then you add a son, it becomes a full family emoji. So if you print family, you get that. And that is the correct way of managing emojis or Unicode. So Swift for now finally gets their Unicode right.
Question.
Yeah, sure.
In that sense, like, where would you get the Unicode for that emoji? Would you use string by transforming to the Unicode equivalent, or would you just manually look up the Unicode and do it that way?
You meant like, how do you get the man?
Yeah, like you've got the /u with the 200D, for example.
Mm-hmm.
Where did you get that from? Did you look it up, or?
Oh, so that's a joiner. So basically that's like on the Unicode 9 website. It tells you that this is a joiner with no space. So you have like a space, joiner space, and you have like a no joiner space. So it just gives you a space, or it joins it, but no space. So. Thank you. Good. And at each point of time, when you say what is the count or what is the length of your string, that also shows correctly which is 1. So, right, now if you want to have a look, as I said quickly, that was the radar I filed, and it had all the things, because my point was that if Python can actually kind of manage the skin tone and everything right, then why can't Swift? Now, we are in Melbourne. It's a multicultural place. There's a Fitzpatrick scale, which tells you about the different skin tones. So here's some code again. So let's create an enum with some skin tones. Right? And a small little function which just skins a character. Basically what it does, it takes a character, whatever you have, and adds a skin tone as an enum. Right? And let's say we have Simpson Man, which is yellow, because Simpsons are all yellow. And we skin him. I mean, it doesn't sound right. But the function is called skin, so we skin him with a tone which is light, and what you get is a Caucasian. You skin him with medium light. I don't know how the hair becomes black to blonde, but that's how the Unicode is. You skin it with medium, turns brown, just the hair. And if you medium dark, brown skin, brown, dark brown hair, and dark, you get really dark skin and dark hair. So this is also something that you can do. If you want to replace, you can actually replace a skin tone, and it will change the color of the emoji if it has skin tone colors in there. Now, one of the other interesting things with Swift 4, they have substrings. Now, Adam West, poor thing, he's no more with us, but I mean, if he was, he would have, or rather Robin would have said, holy smokes, Batman, they have substrings. Now, what are substrings? Substrings are nothing but slices of strings, which are tag pointers. So it says, this is the start, this is the end, this is the length of the string. So it kind of refers back to the main string.
Are they copies of that string?
Not until you start to modify it. So it's a cow, copy on write. So till you're reading it, all good, but the moment you try to modify it, then it creates a copy.
That's bloody awesome.
That's the whole point.
Yeah.
Should be awesome.
So here's an example. So we have a string called greeting, which says this string is a long string. And we get an index. Now, one of the things with Swift 4 is you need to have indexes if you want to manage them. And it's not really still done very well. It's still a bit of a pain. In the last one, you had to create an index, and then you had to have an offset of characters and so on. But you have single-sided ranges. So you can have something like you get an index for comma, and you can say, I want from the start till the comma. And if you print that, you would get this string. And if you want, as you were asking Matt, if you want to create, you don't want to have the overhead of that string being passed from function to function and so on. You have to cast it as a string, which means it creates a new copy of just that string rather than the whole substring. Now, the problem with that is when you pass it from function to function, just because you had Batman, everybody thinks they are Batman. So the strings kind of keep going on with the overheads. String index overalls. We've got the one-sided ranges, so you can actually say I want from the start to the 10th character, or you can say I want from the 5th index position to the end of the string. However, they can't be integers, they have to be indexes. And an example again, we just saw the one with the comma where we did that. And here again, we can use index. You can get it from creating an index and offset it. In Swift 3, how many of you have used the prefix or the suffix? Where you offset and then, it's not really pretty, is it? I mean, we miss those little brackets. Just open the bracket and say, I want the I element. But because of Unicode issues, you couldn't just use it like that. And there is some really exciting news. Swift 4 is officially over. Swift 5 has now announced is open. So while we're still talking about Swift 4, there is Swift 5 CFPs in that sense already open. And if you want to see more about String Manifesto, there's a link. You can actually see what are the different things they want to add for String Manifesto. And See you till the next time when we talk about Swift 5 maybe.